Hello students, welcome to Short's classes. Today we will be solving some IIT JAM Chemistry questions from 2018. We have question number 15 in hand. The decay modes of C14 and oxygen 14 are, and we have four options given to us. So option A states that it is beta decay, option B states that both are positron emission, C states that beta decay is for C14 and for O14 it is positron emission, and D states that positron emission and beta decay respectively for C14 and O14. So we have to choose from these four options. Now the decay modes are the modes under which a radioactive nuclei can decay. So for C14 it is plus electron, whereas for oxygen it is nitrogen 14 plus. So this is beta decay and this is by positron emission. So subsequently the answer will be option number C, which is beta decay and positron emission for C14 and O14 respectively. So the answer is answer C. Moving on to the next question. Next we have question number 16. Consider the following four xenon compounds XeF2, XeF4, XeF6 and XeO3. The pair of xenon compounds expected to have non-zero dipole moment is, and we have four options given to us. The first says XeF4 and XeF6. The second one says XeF2 and XeF4. The third one says XeF2 and XeO3, and the option number D says XeF6 and XeO3. So we have to choose the correct option among these four which have non-zero dipole moment. So starting with the first option, that is XeF4 and XeF6. XeF4 has a structure which looks like this. This is Xe atom. Here we have fluorine. This is fluorine. Here again we have a fluorine and fluorine here. So here we have the lone pairs. So basically this is like this. Now here the net dipole moment, this is the dipole moment, cancels out, so this will be 0. For XeF6 we have Xe, this is square planar structure. For XeF6 the structure is something like this, 4 here and again 4 here, but there's a lone pair on Xe, so it will be somewhere around here. Hence the net dipole moment will not be equals to 0. But since we have to find that the non-zero dipole moment in each pair, so the pair of xenon compounds expected to have non-zero dipole moment, so both the pairs, both the compounds here has to have net dipole moment equals to 0. Since this has a dipole moment equals to 0, so this will not be the option. And for option number B we have to see XeF2. So XeF2 has a structure like this. This is an Xe here, and there's a fluorine over here and a fluorine here, and these are the lone pairs. So basically XeF2 will have a dipole moment which is equals to 0. So and XeF4 we already know it has a dipole moment equals to 0, so it is not non-zero, hence this option will be wrong. For XeF2 and XeO3, XeO3 has a structure like here there is an Xe and then double bond O, double bond O, double bond O, and a lone pair over here. So this has a tetrahedral structure. and the dipole moment is not equals to 0, but here we have XeF2 and XeO3. For XeF2, this is, by the way, linear structure, and since here the dipole moment is 0, so we can sufficiently say that the option number C is not a correct option. So we have remaining XeF6 and XeO3, which is option number D. So XeF6, we have seen it has a structure like this, where the dipole moment is not equals to 0, and XeO3 also has a structure where the dipole moment is not equals to 0. Hence option number D will be the correct option. So the answer is option number D. Thank you.